All right, we're going to work our way through this Unit 9 WU2. So we're going to skip the review part. We're going to focus on our new content today, which is talking about the ellipse. All right, so each of these problems, we're given a certain different kind of information, and our goal is to not only write the equation in standard form, but find all the key features. Now, remember that the standard form for an ellipse is really dependent upon what direction the stretch is at. In this first problem, we're given the graph. And so the way I would start, the vertices are indicated with dots here, is I would connect the vertices with lines. The intersection of those two axes there is your center. So here we know we have a center, and the center is at 2, 3, which we would need. Now, to figure out the orientation, I got to figure out, well, what's the major axis and what's the minor axis? So to figure out which one's longer. All right, so the distance here vertically from one end to the other is 26. So we have, so the length of this line is 26, or the distance from the center to an endpoint would be half that, 13. Now, the other line that connects the other endpoint starting at the center, and so I go from 2 to 14 or go from 2 to -10, that one's 12. So it's pretty circular, they're similar, but it's stretched vertically. So the larger of the two numbers is A and the smaller of the two numbers is B. So 12 is going to be B. The endpoints of this shorter axis are called co-vertices. The endpoints of the longer one are our actual vertices. So the endpoints of the major axis. All right, so 13 is A. And we know our center. We have enough information now to write the equation of this ellipse. So the standard form of an ellipse, if it's stretched vertically, remember the ellipse, both x's and y's are squared, it's set equal to 1. So I'd have x minus h squared plus y minus k squared. Both of these have denominators. If it's stretched vertically, y gets the bigger denominator and x gets the smaller. So x is going to have the denominator of the semi minor axis being squared, b, and a is going to be, a squared is going to be in the denominator of the y, the direction of the major axis. So h and k, that's our center. We said our center was what? Our center was 2, 3. So h is 2 and y is 3. All right. Now, y gets the denominator of a squared and x gets the denominator of b squared. So a is 13, b is 12. So that means y's denominator would be 169, 13 squared. X's denominator is 12 squared or 144. All right, orientation. It was elongated vertically. The center we identified 2, 3. All right, constants A, B, and C. Well, we said A, the distance from the center to a vertex was 13. B, the distance from the center to a co-vertex was 12. We got to figure out what C is. Now, for the ellipse, there's a Pythagorean relation. A squared is equal to the constants B squared plus C squared. So we have 13 squared is equal to 12 squared plus C squared. And we solve for C. I try to pick Pythagorean triples, but it doesn't always work out. So you go solve for C here, that C is 5. So I have all my constants A, B, and C. The major axis length, that's the distance that connects the two vertices together. In this case, the vertices were up and down. It's also, if you like memorizing things, the major axis length is 2 times A for the ellipse. So this would be 26 units long. The minor axis connects the co-vertices together. How wide is it stretched? In this case, horizontally. The minor axis length is always 2 times B. So in this case, it would be 24. All right, vertices and co-vertices. We've identified them graphically. We just need the coordinates. So we have one vertex that's up here at the top, that's at 216, and one that's down here at the bottom, that's at 2, -10. So I'd say 216, and then 2, -10. All right, co-vertices, they are to the right and the left of the center for this one. Those are already identified for me. I'm going to write their coordinates in this block, -10, 3, and then 14, 3. All right, the foci. The foci are in the direction of your vertices, but they are C units away from the center. So my C, we said, was what? C was 5 here. So basically, to get my foci, I'm adding or subtracting C from my center. I'm adding, subtracting 5. So graphically, I go from my center, I'm going to go up 5 units. 1, 2, 3, 4, 5. So we have one focus that's going to be right here. And then I'll have one that's in the other direction between the center and the other vertex. So 1, 2, 3, 4, 5. One's right here. So I'm going to write those coordinates. So we got 1 at 2, 8. And then we have 1 at 2, -2. All right, eccentricity. Eccentricity tells us how elongated or rounded a hyperbola or an ellipse is. Eccentricity is equal to the ratio of C being divided by A. So the distance from the center to a focus divided by the distance from the center to the vertex. So we know that C is 5 and A is 13. For the ellipse, the eccentricity should always be smaller than 1. So that's the first one. Now we go look here at the second one. The second one, we're given a big gnarly equation here, and we want to write this thing in standard form. So I have to go through the process of completing the square, which at times can be awful. So everything here is on the same side. So I'm going to keep my x's and my y's on one side. I'm going to move this constant to the other, and I'm going to start there. So I got 9x squared plus 54x plus 25 y squared minus 250y is equal to -481. Completing the square, life is so much easier when the square terms have coefficients of 1. So what I'm going to do is I'm going to factor a 9 off of the x part. So I got 9 times x squared plus 6x. I got to leave myself some room in here to work. All right, and then we got, I'm going to pull the 25 off the y part. So that'd be y squared minus 10y. Leave myself some room to work. And then we got, still has equals -481. All right, so what I'm going to do is I'm going to pre-make my next line. I'm going to have 9 something squared. We got plus 25 something squared and equals. All right, so you take the squared part. So in this case, x squared, and I drop it down, my next line becomes x. You take this other number, you're going to divide it by 2 and write it down here, so that'd be x plus 3. You then take that plus 3 and we square it, and we'll put it up in this previous line, so 3 squared becomes 9. Now, I need to adjust my right side of my equation. Now, I got to adjust by the amount that I added on the left that wasn't originally there. I put a 9 up in that spot, but it's really 9 times 9 if I was to multiply it out. So my adjustment is I have to add 81 to the right-hand side. Then we go do the same thing with the left. So the y squared becomes a y to the 1. I divide the number in front of the y to the 1 powered by 2, so that makes -5. You then take the -5, put it back up in this previous line, you square it, so -5 squared makes 25. All right, and then we need to adjust the right-hand side of the equation by the amount that we put on there. And so I remember, it's not just 25. We had 25 times that 25, so I'm going to have to add 625 to the right side. So we're going to take 625 and add 81 and -481, and that gives us our right-hand side here of 225. Now, we're one step away from having this in standard form. I need the right side to be a 1, so I'm going to divide every part by 225. and I'm going to write what I have. So in simplifying this, we have x plus 3 being squared over 25 plus y minus 5 squared over 9 is equal to 1. 25 over 225 is 1 over 9. 9 over 225 is 1 over 25. That's where the numbers come from. Here's our standard equation. So we get all of our intel. So orientation. I determine orientation, the stretch of the ellipse based on sizes of denominators. X has the bigger denominator, so it is stretched along the horizontal. So it's going to look something like this there. The center, h comma k. So x minus a number should be x minus a number, y minus a number. So my center, in this case, would be negative 3 comma 5. All right, now that I got a center, I'm going to go put a point on my graph. So negative 3, 5. I don't have a grid. All right, so we'll make a sketch at the end. All right, constants. The larger denominator is a squared. So square root of 25 is a, so a is 5. B is the square root of the smaller denominator, so b is 3. I need to solve for c. Pythagorean relation for the ellipse is a squared equals b squared plus c squared. So I got 5 squared equals 3 squared plus c squared. C would have to be 4. So I got all of my constants. Okay, major axis length. How long is it stretched? In this case, along the horizontal. Major axis length is always 2 times a, so it's going to be 10 units wide. Minor axis length is 2 times b, so that would be 2 times 3, so it would be 6 units tall. Our vertices. So if the orientation is horizontal, your vertices, you add and subtract a from the center. If it's horizontally, you're going to add and subtract 5 to the x value of the center. So our center was at negative 3, 5. So if I add 5 to the x value, that takes me to 2, 5. If I subtract 5 from the x value of the center, it takes me to negative 8. So there's my vertices. Your co-vertices are going to be in the other direction of stretch, so in this case it would be vertical. Co-vertices add and subtract b off your center. So I would add, in this case, b not to the x values because I'm changing vertically. So I'm going to add them to the y value. So my co-vertices will both have x values negative 3. b is 3, so 5 plus 3 is 8. 5 minus 3 is 2. There's my co-vertices. Your foci are always going to be in the same direction as your vertices are, and you're going to add and subtract c units from the center. So my center is at negative 3, 5. My stretch is along the horizontal. So I'm going to keep the y value the same, and I'm going to add and subtract c to the x value of my center. So c is 4. Negative 3 plus 4 is 1. Negative 3 minus 4 is negative 7. I got all my points. Eccentricity is the ratio of c divided by a. C is 4, A is 5, it's less than 1, we're good to go. All right, so we want to make a sketch for this. All right, if we're not given a grid, we can make a sketch making scales here. In the middle of my scale, I'm going to put my center, which is what? I already forgot. Negative 3, 5. All right, for me, X marks the center. All right, then I'm going to go do my vertices. So 5 units along the horizontal in either direction. And then we're going to put our X value. So I got a negative 8, I got a 2. So here's a vertex, and here's a vertex. And then our co-vertices, which we have, are going to be vertically. All right, we go up or down 3 units. I'm just writing the y numbers that I need. So I have a co-vertex here and a co-vertex here. All right, we have our foci next, which are at 1, 5, and negative 7, 5. So we'll put a little F for them. All right, and we're ready to graph this. Now, the way you graph an ellipse is you're actually going to make what's called a central rectangle. So comprised of horizontal and vertical lines. So I'm going to make me a box that passes through my co-vertices and my actual vertices. The ellipse is tangent to the box at its vertices. So it's only going to touch the sides of the box at the co-vertices and the actual vertices. And that kind of helps me draw my ellipse contained inside of here. There's my ellipse. All right, let's go to the next one. See what kind of information we're given. All right, so here we're given 2 vertices, 1 foci. We got to find everything else. All right, so we want to make a sketch for what's going on. Well, we have very limited information here. I got this 2 bits of information. So one thing I know about my vertices is they both have the same y value. So I have a y value of -5. All right, and then we have an x value at -30. So here's one vertex. And then we have one at 28. Here's another vertex. And then we have a focus that is at -22 with a y value of -5. Obviously, this isn't going to be drawn to scale. All right, so what I can figure out first is I know that if I connected my 2 vertices together, right smack in the middle of them should be my center. So I need to figure out what my center is. Well, what you do, figure out the overall distance in between your 2 vertices. You can always do right minus left. So I could do 28 minus -30. And that's going to give you an overall span from the 2 vertices here. The distance in between them is 58 units. So half of that distance is going to take me to my center. Well, half of 58 is 29. So add 29 to the 30 that we're at, and that takes me to my center. 29 to 30, that takes me to -1. So my center, right here, has a coordinate value, or a coordinate of -1, -5. So that's what I'm starting with, -1, -5. I got that. Now, the orientation. Notice how our vertices are sideways. They're horizontal of one another. If your vertices are left and right, your orientation is horizontal. So I have that. Now, what else can we get? Now that I know where my center is, the distance from the center to a vertex is A. Well, we've already discovered that. We said that was 29. So A is 29 units. So I'm going to write A is 29 here. All right, let's see what else we can get. The distance from the center to the focus is C. Well, we know that the center is at -1, the focus at -22, so the gap in between there is 21 units. So C is 21. All right, so we're getting somewhere. Now, notice what we're missing. Well, quite a few things, but we have 1 foci, but we haven't written what the second foci is. There's 2 foci for an ellipse. So we have the 1 focus that's located to the left of the center. Let's get the focus that's located to the right of the center. What I would do, if I know C is 21, all I got to do is add 21 again to the x value of my center, and that would give me the location of that other focus of 21 plus the -1 takes me to an x value of 20. So I have a focus at 20, -5. Okay. Now, we have, let's see, what else can we need to figure out what B is. All right, so I'm going to clean this picture up a little bit and delete the stuff that we don't need. We know what A is, and we figured out what C is, and we got our other focus. All right, so our co-vertices, if our actual vertices are left and right, our co-vertices are going to be vertical. up and down. All right, well, I know the x value of them are both going to be -1. I need to figure out the y value. Well, the distance from the center to a co-vertex is b. So the way we're going to figure out what b is, we got to do the Pythagorean relation for the ellipse. So the Pythagorean relation for the ellipse is a squared is equal to b squared plus c squared. So 29 squared plus 29 squared equals b squared plus 21 squared. And then we'll solve for b. You use a calculator. 29 squared minus 21 squared, square rooted, and you should get 20. So b is 20. Sorry about that. B is 20. Okay, so I know that up and down we have to change 20 units off the y value of our center. So if I add 20 to -5, that takes me to 15. I subtract 20 from -5, it takes me to -25. We can get our coordinates. So we'd have one co-vertex at -1, positive 15, one at -1, -25. So we have that. Now, if we were going to finish our sketch by hand here, what I would do is I'd box this in. And this is very rough, okay? Nothing's drawn to scale. But I make my central rectangle. My ellipse would be tangent to my edges of my box at the vertices. All right, let's fill in all the rest of the information. Eccentricity, C divided by A. All right, we said C was 21, A was 29. Done. Major axis length is always equal to 2 times A. So 2 times A, 58. Minor axis length, 2 times B, 2 times 20, 40. Standard form for an ellipse stretched along the horizontal, x minus h squared plus y minus k squared is equal to 1. If you're stretched horizontally, x gets the denominator of a squared, y gets the denominator of b squared. So I just plug everything in. H and k are the x and the y values of the center. So we'd have x plus 1 squared plus y plus 5 squared is equal to 1. Cannot forget about the denominators. So A's denominator is 29 squared, which is 841. Y gets the denominator b squared, so 20 squared is 400. There is our standard form for the ellipse. Okay, one more. Let's see what we got here. This time all we're given is the foci and the eccentricity. I always need a picture to help me or I start forgetting things. So I'll draw me a little scale here. Our foci, they both have an x value of 6. I got a y value of 2 and a y value of, -14. All right, so we got a focus, the bottom, the top. All right, well, in between our focus, right smack in the middle, should be our center. So I need to figure that part out. Another way, if you got two values and you're trying to find the number in the middle, is just average the two. So that would give you your middle number, the average. So 2 plus -14 is -12. Divide that by 2, I get -6. So my center is at 6, -6. I can go ahead and write that in here. 6, -6. Now our foci were stacked up and down. If your foci are in the same direction of the center as your vertices are, so if they're up and down, your vertices will be up and down, so the orientation is vertical. What does that mean? That means when you start writing your standard form, x minus h squared plus y minus k squared is equal to 1, y has to have the bigger denominator, and x will have the smaller denominator. So, back to here. Now that we know where our center is, we can start finding some constants. The distance from the center to a focus is c. So in this case, to go from the center to a focus, we go 8 units. Say, okay, well, this list of constants that we got to find A, B, and C for, we know that C is 8. All right, so now we're going to look at our eccentricity. Eccentricity is equal to C divided by A. We've determined that C is 8. So if C was 8, that means A had to be 17. Don't always assume that that fraction, that what's on top is C, what's on bottom is A, because it could wind up being not being reduced or written differently. So we knew that C was 8 off our graph, so that tells us that A was 17. So if I know that A is 17, what that means is my actual vertices are going to be 17 units above and below the center. So I'm going to add and subtract 17 from the y value of my center. So negative 6 plus 17, that takes us to 11. And then negative 6 minus 17 is going to give us the other one, which is negative 23. So we have our vertices. So we're going to write those coordinates. So I have one vertex at 6, 11, and I have one vertex at 6, negative 23. And we know A is 17. Well, we need to figure out what B is. You do your Pythagorean relation for the ellipse to find the missing constant. A squared is equal to B squared plus C squared. So 17 squared is equal to B squared plus 8 squared. And then we solve that. 17 squared minus 8 squared is 225. Square root of that's 15. So B is 15. The distance from the center to a co-vertex. See, if my vertices are up and down, my co-vertices are going to be right and left of my center. The distance between the center and that co-vertex is B. So B is 15. So what I'm going to do is I need to get new x values here, because they're both going to have the y value of negative 6. So if I add 15 to 6, I get 21. You subtract 15 from 6, you get negative 9. So we're going to write those coordinates. So we got negative 9, negative 6, and then 21, negative 6. For our co-vertices, we can complete our sketch. Now I know none of this is drawn to scale, but it's still good practice for us, because if we had it in front, something actually drawn to scale, the way we would make somewhat of an accurate sketch is we draw this central rectangle, and this would be tangent to the box. It's a pretty awful sketch here. Tangent to the box at our vertices. All right, we complete finding the rest of the information. Now that we have all of our constants, the major axis length, the length of the line that connects the two vertices is 2 times A, so 17 times 2 is 34. The minor axis length is 2 times B, that connects the length of the line that connects the two co-vertices, so 2 times 15 is 30. Now we come in, we plug everything in, the center, H and K, so we'd have x minus 6 squared plus y plus 6 squared is equal to 1. X gets the denominator b squared, which is 225. Y gets the denominator of a squared, which is 289. And there's our standard form.